Space is often imagined as bright with stars, yet most of it is dominated by darkness. Beyond glowing galaxies lie regions so empty and cold that almost no light escapes them. These vast stretches are not merely shadows, but fundamental features of the universe's structure. Within them, gravity, radiation, and expansion create boundaries that even light cannot always cross, forming cosmic prisons from which escape becomes impossible. Black holes are the ultimate dark regions. Their gravity is so intense that once anything crosses the event horizon, it cannot return. Not even light can escape their pull. These objects represent true one-way boundaries in spacetime. To fall inside is to be cut off from the rest of the universe forever. Trapped beyond the reach of observation, supermassive black holes anchor galaxies, including our own. At their centers, stars orbit at incredible speeds, drawn toward invisible darkness. If one ventures too close, tidal forces stretch and tear matter apart. The darkness here is not merely absence of light but a collapse of spacetime itself. Cosmic voids form another kind of darkness. These immense regions span hundreds of millions of light-years and contain very few galaxies. While not gravitational traps like black holes, they isolate everything within them. Expansion pushes galaxies apart, making escape from these vast emptinesses effectively impossible over cosmic timescales. The event horizon of the observable universe creates a different boundary. Due to cosmic expansion, some regions move away from us faster than light. Light emitted there today will never reach us. These areas are forever hidden, forming unreachable darkness beyond our cosmic horizon. Dark nebulae block starlight with thick clouds of dust and gas. Within them, light struggles to penetrate, while stars may be forming inside. From the outside they appear as deep black patches against brighter backgrounds. Their density absorbs radiation, creating localized darkness in otherwise luminous regions. Neutron stars, though small, create intense gravitational wells. Their magnetic fields can trap particles and radiation. Surrounding space becomes hostile and distorted. In certain scenarios, matter spirals inward with no possibility of escape, adding to the universe's collection of inescapable zones. Dark matter halos envelop galaxies invisibly. Though unseen, their gravity dominates galactic motion. We cannot interact with dark matter directly, nor escape its influence within galaxies. Its presence shapes orbits and binds structures, creating invisible cages around luminous matter. Gamma-ray bursts briefly illuminate darkness, but leave behind regions of devastation. Nearby space becomes irradiated and chaotic. While not permanent traps, these events remind us that darkness can conceal violent phenomena capable of reshaping entire regions. As the universe ages, expansion accelerates due to dark energy. Over billions of years, galaxies beyond our local group will disappear from view. Eventually, distant stars will fade beyond detectability, leaving observers surrounded by near-total darkness, unable to reach or see beyond their isolated region. Inside a black hole's singularity, current physics predicts an end-to-known structure. Space and time collapse to extremes. Escape becomes meaningless because paths outward no longer exist. It is the ultimate darkness, beyond comprehension and beyond return. Even light can be trapped temporarily in gravitational lensing arcs, circling massive objects before escaping or falling inward. These distortions demonstrate how darkness can bend and redirect illumination itself, creating regions where pathways become complex and uncertain. The far future may bring heat death, when stars burn out and energy differences vanish. Without new light sources, the cosmos becomes darker and colder. No new stars ignite, and the universe drifts into near-permanent shadow. Dark regions are not always empty. Sometimes air too dense to reveal their contents. Molecular clouds conceal star birth, and thick dust hides entire stellar nurseries. What appears dark may contain extraordinary processes hidden from view. Cosmic expansion ensures that some regions will remain forever unreachable. Even traveling at light speed would not overcome the accelerating separation of distant galaxies. Darkness becomes not only visual but causal, a separation beyond all interaction. The darkest regions of space are defined not only by absence of light, but by limits of gravity, expansion, and physics itself. From black holes to cosmic horizons, these boundaries shape the universe's structure. They remind us that existence contains zones we cannot escape, hidden behind the deepest and most profound darkness imaginable.